Hi, everybody. We are talking about relations and functions today. This is Algebra 2, and we're in Section 2.1. Our vocabulary looks plentiful, but I believe you've seen most of this before. So, back in the day when we were, I'm going to just do this guy. You know what this is: coordinate plane, XY axis, right? It goes by many names, and we'll talk about it. We might talk about a point back in the day, meaning Algebra 1. We might talk about the location of a point somewhere here. And that point we refer to as 2, 3, right? Because it's 2 on the x-axis, 3 on the y-axis. And let's call it point A. So point A is located at 2, 3, and that's exactly what an ordered pair is. So an ordered pair is, I'm going to highlight this over here. An ordered pair is that right there, right? Tells us the location. Cartesian coordinate. Well, the Cartesian coordinate plane, all of it is one. The Cartesian coordinate plane is just this whole thing here. All of this is called the Cartesian coordinate plane. Sometimes XY axis coordinate plane has a few other words or a few other names that it goes by. Sorry about that. I'm going to move this to the center and make it a little bit larger so we can talk a little bit more about it. All right. So with that in mind, this Cartesian plane or this coordinate plane, Cartesian comes from the name Rene Descartes, who was a philosopher and mathematician. So this plane is named after him, or maybe he discovered it. I don't really know and remember. All right. So the quadrant system is a way of naming each section. And this section would be called quadrant 1. Notice X and Y are positive here. This quadrant is quadrant 2, quadrant 3, and quadrant 4. It's counterclockwise, and it usually uses we usually use Roman numerals to represent that. So now we get into some fun conversation. We're going to talk about relation, domain, range, and function mapping, all this stuff kind of in one. So I'm going to shrink our Cartesian plane away for a few, and let's see if we can talk about any relationship. So if we talk about a relationship, generally a relation is between two things, right? So you might have a relation between you and somebody, as you and someone you might consider yourselves friends. That's a relation. Generally in math, when we talk about relations, we're talking about a relationship between two numbers, right? And so the relationship can be simply as silly as I'm going to say 2 and 3 are friends, and I'm going to say 3 and 1 are friends, and I'm going to say 4 and 5 are friends. Notice I'm writing down this relationship as if it is as if they're ordered pairs. 7 and 3 are friends, and then let's say 2 is also friends with 5. All right, this is a relation I made up. So a relation is a connection between two groups. And so one group, let's say the group of the people that I have in the X column, I'm going to call that the domain. So I've got 2, 3, 4, and 7. 2 is repeated, so I won't write it again. 2, 3, 4, and 7. Okay, so this group is called the domain. It's usually the first number or the first thing that I'm talking about, and I'm talking about its association with another thing. And this next group, where we connect it to 3, 1, 5, 3, 1, and 5, because notice that 3 and 5 are repeated here, this group is called the range. So this relationship I have here has been done in ordered pairs. I can also do this relationship in a form called mapping. And so notice that 2 went with 3, 3 goes with 1, 4 goes with 5, 7 goes with 3, and also 2 goes with 5. This is a mapping of that relation. This is a relation that we see ordered pairs mapping. We could also have plotted these points and represented that relation as a set of points on a coordinate plane. You guys with me so far? All right, let's take it to the next level. Special relations have a certain property, and that relation is that each domain of the range only goes to one. Domain of the range. That was crazy talk. Each domain element only is mapped to one range element. Notice that we don't have that situation here. 2 is hanging out with 3 and 2 is friends with 5. So this relation, though lovely, is not a function. So in mathematics, when we talk about a relation that's a function, let me get rid of this. When we talk about a relation that's a function, we mean specifically a relation where each member of the domain is only hanging out with a single member of the range. All right. The analogy I like to use is birthdays. So if people were the elements of the domain, we've got number one, number two, number three, number four, number five. And I had 365 birthdays here. And I wanted to map each person to their birthday. Each person only has one birthday, right? Each person has one birthday. So that would be a function because one person won't be mapped to two different things. One element of the domain won't be mapped to two different things. I know I'm over talking this, but just stay with me for a minute. Mathematically, we can have a situation where one goes to, well, I can have the numbers 2, 3, and 4, and I can say, well, 1 and 2, and 2 and 2, and 3 goes with 4, and 4 goes with 3, and 5 goes with 3 as well. This would be considered a relationship that is a function, all right? So that's what we have there. Mapping, we already know. So we know what a mapping is. We know what a function is. We know that domain is the group that we map to or associate with another group, and that group is called the range. A relation is just a relationship generally between two numbers. And now we're going to talk about a one-to-one function. A one-to-one function is a function where for each element of the domain, it's only mapped to one element of the range, but similarly, one element of the range goes to one element of the domain. Real quick, this is a function, but it's not one-to-one because notice 1 goes to 2 and 2 goes to 2. 2 technically is connected, 2 in the range is connected with 1 and 2 of the domain. That's not okay for a one-to-one function. So a one-to-one function, I'm going to do it in mapping form again just because it's quick. Let's say I said 3, 5, 7, and 9. And let's say I had 1, 2, 3, and 4. One-to-one functions, notice that the domain and the range have to be the same size, right? Got to have the same number of elements in there. So 3 goes to 3, 5 goes to 1, 7 goes to 2, and 9 goes to 4. This is a one-to-one function because each pair is unique, right? Each pair, each element of the domain goes to one element of the range, and each element of the range goes to one element of the domain. Woo! All right, let's talk about, so we got one-to-one function down. Now there's this idea of the vertical line test. Let me set up for that. So let's say these points on this Cartesian plane or this coordinate plane represent elements of a relation, right? We can use the vertical line test, I'm going to show you in a minute, to determine whether we have a function or not. So here's the graphing representation of this. I'm going to do a different representation really quick. So here we have a table representation of the same relation here that we have going on. So how does the linear or the vertical line test help us out? So the vertical line test says if I have a graphed representation of a relation and I just draw vertical lines straight down, imagine infinitely many perfectly straight vertical lines going straight down. If any of these lines hit two or more than one basically point in the graph, then you know you don't have a function. And you guys can see right here that that's happened, right where I'm highlighting in yellow. And so what you see is that I have 2 points that are hit. So by the vertical line test, that tells me that this is not a function. Let's think about that a little bit more analytically. So what are those 2 points? The points are 2, 1, and 2, -1. Here they are on our table. And what did we say a function is? A function is a relation where each member of the domain only goes to one member of the range. How does this fail? Well, notice 2 is hanging out with 1 and 2 is hanging out with -1. Therefore, when we have it graphically set up, when we graph something and we see that there's more than one x value associated with a y value, you're going to get kind of a layering effect. And that layering effect will fail the vertical line test, meaning that a vertical line is going to hit one of those that point or that part, 2 parts of that graph or that graph twice. Huh? Making sense? I hope that makes sense. We're going to knock this out far. I might have to actually do 2 videos, not because the work is long, just because of this long introduction with the vocabulary. But independent variable, generally refers to the elements of the domain. All right. Dependent variable. So I'm just going to put little domain, domain variable. All right. So generally that's going to be X. Dependent variable, that's generally going to be the range variable, right? The variable used for the range. And that's going to be Y. The independent variable is going to usually be the horizontal axis, whereas the dependent variable will be the vertical axis. And function notation is a bit random. I mean, it's not random, but it is a bit it's going to feel like it doesn't have anything to do with what we're talking about. It's not exactly tied here, but basically it is when you have an equation like this, y equals let's say 3x minus 4. So the equation is in xy, and you know already from last year you can graph this. But if we take that and we replace y with f of x to emphasize that x is the independent variable and y is the dependent variable that depends on x. So we would say y is a function of x. We only use f of x if we're describing a functional situation, like a relationship that's going to be functional. And we'll see more of this in our example. So if I have f of x, let me just do this real quick. If I have f of x is equal to 3x minus 4, and then I let x equal 3, I would say, what is f of 3? Meaning, what is the value of this function when x is equal to 3? And what that lets me know is wherever there's a x, I'm going to plug in 3. And then I'm going to do my calculation. F of 3, as you guys know, 9 times 9 is not, I'm sorry, 3 times 3 is 9 minus 4 gives me 5. F of 3 is equal to 5. All right, I feel like we have had a lot of information here. I'm going to stop this video and I'm going to let us pick up with another video where I'll do the examples, and that should be really short. All right, guys, thanks.